And right now, we have the further version. We have CSMA, for example, any version of CSMA, but right now, we have collision avoidance. Previously, we have collision detection, but this time, we can have collision avoidance. Well, if you want to avoid a collision, how you can avoid a collision? In fact, we use this way, wait for a time period. Once you make sure, okay, indeed, no transmission on the channel, then you think, okay, you double check so you can transmit. You double check, then you can transmit. So this is a kind of collision avoidance. So you see, all terminals listen to the same medium, right? And ready to sense it, so sure. And if a medium is busy, no problem. However, if actually we'll have the actual time and random time start. And even it's idle, we still need to wait a specified time. And so that make sure, double check, and then you can have the transmission. So it looks like this. We have a mobile station A, and I don't know, we pass on frame label. So that's why here we mention frame explicitly. And we have a mobile station B and C sense a medium. For B, actually know the channel is busy, so station B will delay. And station P can resense if we have B and C, but can sense and transmit a frame if it's idle. So currently, we just have the description for this, but we will have for the actual time to wait. But we just show you, oh, okay, no, okay, we have the frame on the channel, so we won't send. So this is a necessary one if the channel is busy. Unless, okay, the channel is idle. So currently, it just mentioned, we have the busy one, then you won't send. And actually, you will make sure that you send, for example, station B is sent. And the C wants to send, so C need to sense. And we have a term, deferred. Sense the medium and defer to send, because currently the medium is occupied by mobile station B. And likewise, oh, okay, now the channel is idle, so C can start transmitting. But start transmitting immediately, no, we still have the predefined time. Currently, we don't have the predefined time. We just mentioned, okay, maybe you make sure then you can transmit. And so that you avoid to have a collision by sensing the channel at this idle, then you send. So the minimum requirement, the channel should be idle. But actually, we have the current time. We need to wait DIFS. All right, so we have a time period called interframe spacing. We need to have the time spacing, but here we call it the interframe spacing. We need to start the transmission, but you need to wait the actual time. It's called the DIFS. Here we have the term D, distributed. So we have the distributed IFS, and this is a time period. You need to have the actual time period, wait for this, and then double check the channel is idle, then you can transmit. All right, so currently we have the actual time. So wait for the actual time, then you can have the next possible transmission. And in fact, if we have a CA, and CA actually allow the IEEE L2.11 that says Wi-Fi to use CSMA series. So this is Wi-Fi, employ this version. And we have a Wi-Fi using, so of course we need to have the contention. So we'll put contention window into the current discussion. So we will defer and waiting for this. Actually, once we will have the window, but we don't mention the window for you. So we will have a window. And the window actually is the actual one, so we don't have the specific procedure, but we have the window. If we have the window, it says we will count down the window size until the window size becomes 0, then it has a chance to transmit. So each one, when it will have the chance to transmit, it doesn't mean the system is idle. We will have a system idle, the channel is idle, and also the current transmission can transmit or not. It needs to count the window. So we have the window, for example, the remaining window for station A and window for station B, they have the initial value 25 and 20. And all of them can count down till it becomes 0. Then it has a chance to sense the system is idle or busy. So we have an operation like this. And we have the interval. And all the interval is called the backup interval, because right now, backup we need to count down, and when we will decrease. Actually, if the channel is busy, now it's busy. Similar, we have ticks. We have 20, we need to count ticks 1, ticks 2, till 20 then becomes 0 for base station B. So it says we have a backup interval and count down. And actually, how to have the interval for A and B? Actually, we have a contention window 31, and we choose one value from 0 to 31. And here we assume A choose 25 and B choose 20. So we have the random backup interval, random, because we have the specified interval from 0 to 31, and we have the random backup interval. So we choose a random value lower than 31. So here we have 25 and 20. So that says, okay, have chosen a backup interval of 25 and 20. So currently we have all the settings for station A and station B. Well, if we have 25 and 20, why? Station B will reach 0 before 5 units earlier than mobile station A, because we have the same condition. If the channel is busy, then the window will count down, and when the station will freeze to count down if the channel becomes busy. All right, so possibly we have the other station, so they won't stop counting down, and they will stop counting down, and so that the window will be frozen. So here, if we assume no frozen, maybe 20 ticks later, we allow station B reach 0, and then B has a chance to transmit. So that says we have this 5 units of time a bit earlier than a mobile station A. It says, okay, when this happened, then station A noticed the medium becomes busy and frozen its backup interval. Currently, it's 5. So here we already have 2 stations and assume no other station. And the station A and B can allow the backup interval to count down 1, 1, 1, and until 20. So mobile station B reach 0, and mobile station A reach 5. And 0 actually we still have the time to wait. But right now we assume, okay, at this station B will find, okay, the chance for station B becomes a bit earlier than station A, and find, okay, if the medium is busy, then it can try first. Because it can try first, so A will notice medium will be busy, because B will transmit earlier than A. If B transmits, so the medium becomes busy. Busy, I don't know, it will freeze the backup interval. Even we have a five for the countdown timer, but A freezes. Once the system becomes idle, then the timer will count down till 0. If count down to 0, and then A can transmit. So currently we have the inclusion of a backup timer for the collision avoidance. You see, if we can count down to 0, as soon as the medium becomes idle again, A resume backup countdown and transmit once the countdown, the backup interval reaches 0. So when it will reach 0, possibly 5 time units later, then A can reach the 0 backup countdown timer, a countdown interval, and so that A can transmit. So up to now, CA, we have collision detection and the time interval. So look at this. 1, 2 to 20 later, then B sense the system becomes idle and transmit. And during the transmission, A needs to count down again. Once reach 0 for A, and A can transmit. All right, so this is the backup countdown interval. So right now, we use backup interval in collision avoidance. And also, we have the time interval before the transmission, DIFS. And perhaps we have the others. Okay, right now, B. Here maybe something different, but this one actually maybe not the current one. So this one is 20. And here it says, oh, okay, how about B want to transmit again? So initially maybe B set it to 15, lower than 31. And because A still have a 5, so 5 later we have a 10 for B. So this is the complete story for the current figure. Initially, we have 20 and 25, and finally we have 15 for B only. And so that after the transmission of A, and then B still need to count down for 10 units for the backup interval. All right, that's it. So this is the whole story for the current figure. Then you have 2 minutes to check this. Talking about backup interval here. And for time to wait, later we will have the further discussion, but check this first. So that's why we have a random delay half CSMA CA. So this is a random backup time.